Jai Hind everyone. I am Achintya Pandey as Assistant Professor in Department of Information Technology at Ajay Kumar Garg Engineering College. Today I am going to present my video on database system concept and DBMS. Okay. Here we will discuss the overview of database and its basic concepts, right? So, this is the outline, this is the content of my today's video. Okay. So, here we will see the quick eye view on following topic, especially DBMS and database system concept. So, first, what is database? So, database is a collection of interrelated data, I mean interrelated relations, okay. And DBMS basically, DBMS is database management system, which is a software, a big software, which is used to manage database, that is the relations, and manage means doing everything. Since it is system, so it I mean managing all kind of activity like storing, right, like how the data is going to stored, how the data is going to manipulate, access, view and all that, okay. So, it is contain information about a particular enterprises, right, and I mean everywhere the database you know, from daily life to all application where database is usually used. So, it will be like said that it is a collection of interrelated data. There are set of program to access that data and an environment that is both convenient and efficient. These all are few applications of database management system where we usually use there, like banking, transaction process, airlines, reservation and schedule, university, sales, online retailer, manufacturing, human resources. So, from even retails and all there we use database. So, here we see that from human resource to banking, airline, all where the database is usually from very beginning, okay. So, database can be very large. So, database touch all aspects of our lives, like we have seen, because the database, I mean there must be interrelation among the relations. Here we will use the term relations. So, particularly the database, we are talking about the database. So, mainly we are talking about the relational database. And what is the relational database? So, relational database means we are talking the tables in terms of tables, right. Relation means table, okay. Basically database could if we model the data, so this could be relational, this could be object oriented, this could be XML and kind of these all are model. So, basically we are going to explore the relational database management system, like, okay, where data will be in the form of tables, okay. And in this context we the table is called relations. So, everything will be in the tabular form, okay. Okay. So, university database example, like register student for the course, add new student, instructor and course, assign grade to student, okay. So, in early days database application were built directly on top of the file system. If we I mean just view in the past, so there were used file system. So, in the file system there are many drawback, okay, and this particular relational database management system overcome that drawbacks, okay, of the file system, okay. So, these all are the basically drawback which is found during the file system. So, particularly we this DBMS or especially relational database management system overcome these drawback which been found in the file system. So data redundancy and inconsistency. If we are going to use file system which we use in early days, so there will be a problem of redundancy and inconsistency. Means what is the data redundancy? Data redundancy means you can consider like multiple copies of same thing is found. So we can say that they are not, if something is I mean a multiple copy, so this is redundant. Okay, one thing has so many replica, so this need to be overcome, this need to be resolved. Okay, so data redundancy and inconsistency is greatly removed using the DBMS database management system. So these all are few drawbacks which been overcome in the database relational database management systems. So next drawback is difficulty in accessing data. Okay, so if we are using file systems, so we will, because the data could be in the form of the data could be in different formats and all that. Okay, so how you are going to make this data into structured. Okay, so we use the relational and database and can make the data in a structured format. So these all are the difficulty faced during file system. Data isolation, like multiple file and format, integrity problem. Okay, how we going to maintain the constraint which must be satisfied by the data value. Okay, so if we use file system, so these constraints occur and we could not overcome that. Okay, so by using the DBMS we will see that these problem could be overcome. Okay, okay, atomicity of updates. Okay, failure may leave database in an inconsistent state with partial updates. Okay, atomicity of the atomic instruction. What is atomic instruction? Atomic instruction means either the instruction execute fully or doesn't execute. Okay, suppose in transaction system if you are going to transfer $50 from one account to another account, and for example if you are going to quote what could be the statement, so you could write like say read A. Suppose if you are going to transfer $50 from A to B. Okay, so what the code could be written, read A equal to A minus 50, write A. This could be. Similarly here B, you could have read B. Okay, read B, B becomes B plus 50 and write B, write B. Okay, so these instruction could be atomic. Okay, atomic means this could not be situation where an account been deducted, say here if an A been deducted by $50, so parallelly B must be added. No, so these instruction could be executed fully, not partially. Okay, either execute as a whole or doesn't execute. It could not be the case like A has been deducted and B has not been modified. Okay, so these kind of instruction are where the transactions occurs, where the updations are there. It must be, and these kind of instruction must be atomic. Okay, so the feature of atomicity must be there. Okay, so if we use file system, we have been found that maintaining these kind of transactions were not possible, right? So next one is concurrent access by multiple user. Okay, so a transaction, for example online transactions, railway reservation and all, so many users at a time accessing. Okay, so how you are going to maintain, okay, so that serializability in all things could occur. Okay, but this is not the case if you are using the file system. So concurrent access by multiple users while in file system, while using file system, so the maintaining these things are not were not possible, right? Okay, security problem. Okay, so these are some I mean problem which being faced in file system, like security, concurrent access, atomicity of update, integrity problem, data isolation, difficulty in accessing data, and data redundancy and inconsistency. Okay. So database offers solution to the all above problem. Okay, because if we are going to make data in say structured format, so there is a there we can maintain the all these things. Okay, like inconsistency up to the great extent. Okay, extent we can eliminate using concept of normalization and all that, and all the properties we can maintain. Okay. Okay, level of abstraction. What is abstraction? So abstraction is basically an act of representing essential features without including the background detail. So here we can see the database are the abstract data in term, I mean in these form: physical level, logical level, and view level. Okay, so level of data you could see at physical level, logical level, and view level. So what is physical? Physical level basically discuss how the data is going to be stored. Okay, so this discuss how a record is stored. I mean in hard disk how the data is going to be stored, the organization of data, how it is going to be stored, right? Logical level basically describe the data stored in data and the relationship among the data. Basically logical level we mostly focus, mainly focus on schemas, design. Okay, what are the design of the database, and if you are talking especially which we use relational database, so how we are going to make the relation means tables. So this is called schema. So logical level include what is the name of relation, how one relation is going to relate with another relations. So these all kind of relationship among the data, means among the relation, is under the logical level. Okay, like if we are talking about say student management system, so this could be what could be the relation, what are the attributes of the relations, what are the constraints that must satisfy by the attribute of that relation. These all things comes name. In mainly we can say that the name of relation, the attribute list, what are the type of attributes, or you can say the constraint which must satisfy by the attribute of that relation. These all comes under the logical level. Okay, and view level, it means how the user view it. Okay, so application program hide details of data types. So view can also hide information for security problems. So this is the an architecture of a database. Physical level deals with the storage. Storage means how the data is going to be stored in the hard disk. Okay, logical level means ki, schema. Schema means what are the names of the relations, what are the attributes of the relation, how one relation is going to relate with another relations. So all kind of interrelation, interrelated data. So these things, all those schema comes under the logical level. And view level, a user could have view 1, view 2 and view n. Okay, so this is the architecture of the or view of the data. Some more terms are used: instances and schema. Like said, what is the schema? Schema means design of the database, and instances means the design of the data at particular time. So instances is time basis. Like suppose a relation is student. Okay, suppose student is a relation, and you can create as many attributes as you require for any particular application. Okay, so students, for example, student name, student roll number, okay, student address, student mobile number, student ID, and so many attributes. Okay, So this is called schema. And say for example another relation is department. Okay, so mainly schema means name of the relation, like student, department, name of the attributes, here department like department ID, department name like department HOD name, department phone number, and etc. So what are the name of relation, what are the attribute you are going to include, what are the type of attribute means what are the constraint of the attributes. So these all comes under the schema, basically the logical schema. Okay, so the overall logical structure of the database include all those. Okay, one thing is in general it is called integrity constraint. So what are the integrity constraint? Means what are the value which must be satisfied by the attribute of the relations, that is called integrity constraint. And in relation they are four. One is domain constraint, okay, another is key constraint, third one is entity integrity constraint, and fourth one is referential integrity constraint. So domain constraint means the attribute must satisfy domain constraint. Domain constraint, suppose if an attribute is character, so that attribute cannot take integer. Okay, so that is called domain, must be within the domain. Okay, key constraint means every entity or every relation must have a key. Okay, key means the attribute whose if two entity will not have the same value over that attribute, so that attribute is called key. Okay, so an entity or a relation must have a key. This is called key constraint. Okay, similarly we have entity integrity constraint, means key cannot be null, and last one is referential integrity constraint. So RIC is basically RIC means a relation is going to relate with another relations. So this could be done by the making foreign key and primary key. Okay, say one relation is going to relate with another relation by some common attribute. Okay, so if that common attribute is primary key in the second relation, this one is called, then the attribute of the first relation is called foreign key. Let's say with here we have discussed student and department. Suppose student is having student roll number, student name, student ID, and department ID. Okay, so student and department will be related if there is some common attribute. So this common attribute here we can find like department ID, student belong to this department, like student belong to CS department, IT department. Similarly department is there. Okay, so if a relation is going to relate with another relation, so this can be done by some common attribute, like here student and department, we have the common attribute is department ID. Okay, okay, so here the constraint is like student cannot exist without department. Okay, but department can exist without student. Okay, a department can exist without a student, but student cannot exist without department. Okay, so in the department relation, the department ID will become the primary key, and in the student relation the department ID becomes the foreign key. It is called foreign key. Department ID particular this attribute will be the foreign key, and in the department that particular attribute will be the primary key. So through department ID attribute, student and department will be related. So this is called referential integrity constraint. Okay, and this constraint itself, like the domain of the both attribute must be same, and foreign key, here student ID, department ID. Okay, so this must be subset of this attribute, department ID. Okay, or you can say this relation particular, in general this relation is called a referencing relation, and this relation is called reference relation. So the referencing attribute must be the subset of a reference attribute. Okay. So this is what comes under schema and all that. Okay. So physical schema is what? Physical schema means the overall physical structure of the database is called physical schema. What is the instances? The actual content of the database at a particular point. Okay. I mean instances changes over the time. Okay. Like student at this time, suppose a student been pass out, so they could be removed from the student list, current student list. Okay. So instances may change time to time, but schema cannot change infrequently or frequently. Okay. Schema changes infrequently. Okay. Next term is called data independence. So one property is called data independence. So what is data independence? So basically data independence is the capacity to change one schema, I mean one level of schema without affecting the change in the higher level schema. Okay. So that is called data independence. It is the capacity to change, to change in one, capacity to change one level without changing or without affecting the change in the higher level. So there are two types of schema. One is physical data independence and second one is the logical data independence. Okay. The physical data independence means if suppose if you are going to change in the schema, physical schema, I mean how where the data is going to stay. If you manipulate, or you can say suppose change the storage means and how the data is organized, you just rearrange. Okay, right? Okay. So if physical storage is going to change and that change doesn't affect at the higher level, then this is called physical data independence. So it is comparatively easy to achieve than logical schema, because if you are going to make change in the logical schema, okay, I mean the relation and all that, say you are going to remove some attribute and all. Okay. So that change, if you are going to not reflect in the higher level, I mean user level, it need it is quite tough than the maintaining the physical data independence. Okay. Like suppose these all things are here, as a physical story you can see, like if mobile is here, this one is here, and you are going to replace here, this one is here. Okay. So if you rearrange the storage structure, so that doesn't affect the at view level, at user level. But if you simply change the schema, I mean logical schema, so they will reflect. There may be, I mean it will be tough to maintain. Okay. That upper level should not change. Okay. So over physical and logical data independence, physical data independence is easy to achieve rather than logical data independence. Okay. These all are the few data model. Okay. I mean relational, ER, object oriented, semi structured. Okay. So they are mainly 4 models are being used: older model and network hierarchical model. So relational model means you are going to maintain data in particular as a tabular format. So that is called relational model. Okay. Table. So that is called structured data. ER model means you are going to perceive data as a everything as an entity. Okay. And an entity could be associated with another entity by relationship. So this model is called ER model, entity relationship model. So there are 4 basically data models. One is relational model. Relational model means you are going to maintain the data in tables, and that table is called relations. And in ER model, you are going to see the data or everything as an entity, and how an entity could be related with another entity. Okay, how an entity could be associated with another entity. This come under the model ER model. Next one is object based data model. Object based, you are going to consider it as everything as a class, collection of similar type of object and all that. So object oriented model and semi structured data model means like tabbed and all that. Okay, we are using HTML. So these are four popular data models. Like this is the relation, like it is what relational data model. Everything is under the table. So here rows and columns are there. So every row in context of database is called tuples, like, and the table itself is called relations. In context of database management system, the table is called relation and the rows is called tuples. Okay. These are, say here, instructor table, the department table. Okay. So if any table, I mean more accurately it is called, if any relation or table is going to relate with another relation or table, so there must be some common attribute. Like suppose the instructor table you want to relate with the department table, so there must be some common attribute like ID name and department name. Here department name, so here department name in both I mean table or relation is common. So this could be related with this one. Okay. So in one table this particular attribute is made as a primary key, and in the first one it becomes the foreign key. Okay. Next one, database management language could be categorized under the DDL and DML. Okay, so in DDL, how you are going to create the database schema. So this is just the command using SQL and all. You could create the table, I mean relations. Like here we are going to create instructor table, ID, name, department name, salary, all. Okay, so DDL compiler DDL compiler generate a setup a template stored in a data dictionary. Okay, so in DDL this is DDL, and DML is going to manipulate everything like select star from instructor. Okay, adding, deleting, everything operations comes under the DML, and creating the database, creating the table, identifying the attribute, what type of attribute, how many attribute. Okay, updating it. Okay, like you are going to change. So this come under the DDL, data definition language, and data manipulation language contains, it is also as a query language. So SQL is widely used for commercial, like you are going to project something. Okay, project some part, some condition which must satisfy that relation and all. So this come under the DML. Okay. SQL is basically, it is a basically standard just for how you are going to query and all. So okay, we have already. Next one is database engine. So database engine basically has three parts. One is storage manager, second is query processing, and third one is transaction manager. Okay, query include three phases: parsing and translation, second one is optimization, and third one is evaluation. Okay. Next one is transaction management. So what is transaction management? So a transaction is a collection of operations that perform a single logical function in a database application. Okay, transaction like concurrent transaction. So many users are going to perform I mean same set of operations. Okay, so that is called transaction. So transaction is basically operation. Like here we have seen that if you are going to transfer $50 from one account to another account, so these operations like read a, write a, all those operations, and we make how we are going to make atomic instructions. Okay, comes under the transactions. Okay. So this is database user and administrator. These all are several type of database user like nav user, application programmer, sophisticated user, the TBA, database administrator. So nav user basically use application interfaces, application programmers write application program, and like analysts or sophisticated user use query tools and these DBA use administration tools. So if you are going to show the overall structure of the database management system, so here we could represent. So we can see that at one level there is a types of user like nav user, application programmer, sophisticated. Okay, so at second we have the query processor, and at third we have the storage manager, and at last we have the disk storage. So disk storage, basically this comes under the physical schema. Okay, physical schema, how the data is going to stored and all that in the hard disk. Okay, so like we have also discussed physical data independence. Suppose this is the hard disk and data is going to store like this. So if this particular data is going to store here, or this particular data is going to store here, I mean there is a just you make changes in the storage at physical level, so that change doesn't bother to change at this level or higher level. So this independence is physical data independence. Okay, and it is quite easy rather than if you are going to change in at a logical schema. Anyway, so this is the, you can define the overall structure of DBMS system. At top level we have the set of users, at next level we have the query processor, how all these different types of query like nav user or even sophisticated user or DBA write everything in terms of query. Like in a structured or relational, there must be query, and that query must be executed. Okay, so this phase, at first level, at higher level, there will be users, types of user basically, and they put query. Request will be in the form of query. So query processor is going to process all those queries through using all these modules. Okay, like application program code, like object code, compiler, YAML query and all that. Okay, so we have users, and user put the request over by the query using these kind of tools. Okay, query processor is going to execute or process the query. Okay, and then storage manager, like buffer, file and all these manager will be responsible to store and communicate. Okay, so at last level, that is the physical schema. Okay, so this is the internal, or you can say the architecture, what is this is the database system internals, or you can see the structure of the database management systems. Okay, and first level there will be set of users, second level query processor, third level storage manager, and last level disk storage. Everything will become under that. Okay, okay, this structure could be, database architecture could be centralized, client server, parallel and distributed. Okay, like centralized client server, like www is the client server. So here what client put request and server process that request, that is called client server. Okay, centralized means the server is one. Okay, similarly parallel and distributed. Okay, so basically here we are going to say what is if we are going to conclude, so here we have just say what is database, particularly the relational database, because we are going to use Dbms here throughout. Okay, so database is collection of interrelated tables. Okay, or more appropriately you can say that collection of interrelated relation, because table is called relation in relational database management system. Okay, so and how a relation means a table could be related with another table, means another relation, that is how one relation is going to relate with another relation, that is determined by the some common attribute over that relations. If there is no common attribute, one relation cannot relate with another. So finding that common attribute while designing the database and all is a critical thing. Okay, how we are going to identify this is the common attributes. So we would have to identify. So by that common attribute, a relation could be related with another relations. Okay, so by that way we make primary key, foreign key and all that. Okay, so collection of, that's why we database will be, database is what, collection of interrelated relations, and DBMS is going to use the database. Use means how the database could going to stored, how we are going to manipulate, and all those every operations that could be performed, access and all these things comes under the DBMS. It is basically a large software, okay, which is used to manage and access and doing all kind of operations over the database. Okay, and we have just seen the database system management, some concept like schema, instances, data independence, the overall structure of the DBMS and all that. Okay, so thank you everyone.